All right. Hi, everybody. My name is Wilson Lin. I'm the technical director for UCLA NanoLab. It's hard to follow Matt, but we work closely together. He had tons of beautiful images with a lab that I'm making devices for them. What we do, we can read this, but basically we're making chips or devices for your daily applications. All the way from your cell phone, computers, your car, biosensors, drug delivery systems, even artificial eyeballs. We make all kinds of devices in our lab. So you have any crazy idea you want to make, come to us, we can help you make them. All the devices were made in the clean room. For some of you who don't know what a clean room is, imagine in a 1 cubic fluid volume like this. Classroom 100, you have about 100 particles at 0.5 micron size in this space. In the air in this room, we will have about 1 million particles that size. So the clean room is extremely clean. So when you enter the clean room, you have a gown like this with your clean room gown, your face mask, gloves, shoe cover to protect particles from contaminating your wafers. Also, we have one of the most state-of-the-art clean room filtration systems. All the air will push from top to the bottom, push all the particle to the bottom of the floor, a circular air back to the filter for you to provide a very clean environment for your devices. So this is like 1 minute introduction was a clean with this. These are my team, my staff. We have total 10 staff on our team who have extensive experience that can help you either train you on the tool or make you make your devices. We have over 100 equipment in our lab, and we like to break the tool into 3 categories: lithography, deposition, and etching. In terms of lithography, we have e-beam lithography who can write a sub-micron devices. We have optical lithography can write feature size about 1 micron and above. We recently just purchased 2 brand new direct writer tools. One can write about 300 nanometer system, and the other one can write about 600 nanometer feature size. We also have wide range of imaging systems, SEM, FIPS, and we also purchased a brand new top-of-the-line SEM tool just recently. We work very close with Matt about the imaging system that we sort of use each other to sort of complement each other. In terms of deposition, we can deposit metals, insulating films, dielectric, polymers, and the technology that we use can range from e-beam evaporator, spotting tools, chemical vapor deposition, PECVD or LPCVDs. We also can do spin-down photoresist, any kind of creative way that you can deposit the film on your substrate. We know how to do it. So talk to us, we can help you with deposition. Once you have your film deposit, then once you have the lithography to pattern your features, next step is etching your process. There are 2 ways to do it. Typically, people will use a plasma etching, which is a vapor phase etching system. And we also have a wide range of wet chemistry allow you to pattern your devices. Once this is done, then we'll take an image to look at how the wafer looks like, what's the cross-section on your device, and how they look. And we also have a lot of electro measure systems that measure CV/IV, electro property of your device. If you're interested to learn more about our lab and what do we do and want to learn how to make devices, we offer a wide range of classes in our lab. If you're UCLA students, we have a quality fabrication class. We make CMOS, MEMS, and other devices. We typically have over 150 undergraduate students go through our program. If you're a graduate student, we partner with physics department who also learn the similar clean room experience as well. If you are non-UCLA students, we also offer summer programs, which allow students to come in, spend about 2 weeks with us, and we will show you what the clean room environment looks like and how to make a device within our lab. All right. Good. All right. If you guys, I know it's a very short version of what clean room does. If you have time, come down here at 2 o'clock. Myself and some of my staff will be there to show you the lab, to talk about more detail, what we can do and how can we support your research and your fabrication process. All right, thank you.